Hello and welcome to Patch Math, where today we are going to discuss systems of linear equations. We are going to go ahead and focus in on our special cases. And in this video, oh, the highlighter is not working properly. In this video, we'll be looking at special cases through substitution. Now, this problem is set up easily for graphing. Oh, we had to go ahead and stick those into your graphing calculator and you'd easily be able to see the solution. However, let's just assume that you were asked to use substitution on this problem. So if we were going to do that, we'll see that we actually have both of our variables solved for here. That makes our life a little bit easier. That means all of this y is equal to all of this y. We can put one y equal to the other. So I'm actually going to color code this so it'll make a little bit more sense. So you're going to see we have the negative 2x, that first y, plus 2. All of that went right here for that y, okay? We just nested it right in there. And it doesn't matter. You can put this y in for that y or vice versa. They're gonna be the same thing, so please don't worry. All right, and all of that is equal to everything that I have in the green circle because that is what the other y. These are the exact same y. All right. You'll notice each side itself is simplified. There are no terms to combine on either side independently, so we can start our solving steps by bringing the variables together. I would go ahead and add the two x's. Opposite operation on both sides of the equal sign. That is a negative 2x, so we add it to cancel it out. And this is the situation that results in the special case. You'll see that we end up getting 2, that's that pink 2 right here, equaling negative 2. And then we ask ourselves, is this a true statement? And the answer is no. There is no universe in which a constant 2 is ever equal to another constant negative 2. There are no variables here to modify them, nothing interacting with the 2 and negative 2. So this is what we call a false statement. And when we get a false statement in mathematics, that is no solution. Now, if you are new to systems, you may be wondering, what did we just find? All right, what are we looking at? Remember, we're looking at a system of linear equations. In other words, traditionally, a solution to the system of linear equations is a point of intersection. If we have no solution, or if we do not have a solution, we end up getting a set of parallel lines. And that's why at the beginning of this video, you probably heard me say that if you graph these, you could easily determine that this is no solution. No solution systems never intersect. That's why there is no solution, all right? They end up having the same slope, but different y-intercepts. And that is a very easy way to recognize this. Notice, same slope, different y-intercepts. Back when you were learning about parallel and perpendicular lines, you learned about this topic. And we found that parallel lines never intersect. And that is because they have the same slope, but different y-intercept. All right, well, there you have it. That is how you notice the special case of parallel lines. In other words, no solution, no point of intersection for the system of linear equations. Your math knowledge has just been patched. Thank you so much for your time.